Bright Tuty. Every student matters.
Hello students. I told you how we produce sounds, right? In the topic voice produced by humans, sounds produced by humans. We learned how we have a voice box and how we use it, how it is used to produce sounds that helps us in communication, right? Now we hear sounds through our ears. If I am producing any sounds, but it is not able, if you are not able to hear it, then there is no use of that production, right? There must be a receptor of that sound as well. Whatever I am speaking, you are able to hear because of your ears, right? We hear sounds through our ears. Now let us see how. The shape of the outer part of the ear is like a funnel. You can look at your own ear for this reference. You have the outer part of the ear that looks like a funnel, right? Like if you pour water, the water will pour in like a funnel. You do not have to pour water because it may harm your ear. But this is just an example that your outer part of your ear is like a funnel, right? When sound enters it, it travels down a canal at the end of which there is a thin stretched membrane called the eardrum. We will be looking at the diagram as well. What basically you have to understand is that there is a funnel, then there is a canal going in. You can touch your ear for that. There is something of a canal going in, and at the end of this, like this is the ear, outer part of the ear, right? And then there is a canal going in, and then inside, at the end of it, there is a stretched membrane. This membrane is the eardrum, right? It performs an important function. It has a very, very important function. Eardrum is very important. Let us see the function of an eardrum, right? Take a plastic tin or a can. You can take the reference of this picture. Take a plastic tin or can, cut its ends, right? You have taken a can and you have cut its end. Stretch a piece of rubber balloon across one end of the can and fasten it with a rubber band. You have taken a can and then you have put a balloon at the end and you have put a rubber band. This is the balloon and you have put a rubber band on it, right? You have cut the plastic can and you have put balloon on one side and you have put a rubber band to hold it, right? Put 4 or 5 grains of dry cereal on the stretched rubber, right? Now, on the end you have put 2 to 3 grains, right? Here basically you are putting grains, right students? Now ask your friend to speak any sound. You can also say to speak hooray, hooray or anything you want. When he speaks through this end, this is the end which has the balloon, and when he speaks through the other end, basically the grains start vibrating and they go into the air. The grains were earlier on the balloon, now they are into the air, right? From the open end, observe what happens to the grain. Why do the grains jump up and down? This is because the sound coming from here reaches this balloon and the balloon starts vibrating, right? This balloon vibrates and hence the grains start jumping up and down. This is a very smart activity to understand the function of an eardrum. This rubber balloon is acting like an eardrum here. So what did we learn? When you produced a sound, this eardrum started vibrating, right? Due to these vibrations, we were able to hear the sounds. We are able to hear the sounds because of this eardrum, these vibrations, right? Inference. What have we learned from this? Let us come to a conclusion. The eardrum is like a stretched rubber sheet, as we did in the activity, the balloon, stretched rubber sheet. This is the funnel part, right? This is the canal, and at the end, this is the eardrum, right? Sound vibrations make the eardrum vibrate. As you speak, the eardrum of your ears, because you are able to hear your sounds as well, these sound waves also travel to our eardrums, due to which the eardrum vibrates and we are able to hear what we are speaking as well, right? The eardrums send vibration to the inner ear. Now this is the inner ear, as you can see in the picture. This is the eardrum. The yellow part in this picture is the eardrum here. These eardrums, this eardrum basically sends signals inside the inner ear, right? From these signals, a signal goes to the brain. From the inner ear, you will be learning in detail in higher classes. From this inner ear, the signal is sent to our brain. and the brain functions instantly and tells us what is being spoken, what are you hearing, what is the kind of sound that you're hearing. Is it your water running? Is it your friend speaking? Is it a bell ringing? You are able to understand because of your brain, right? This is how we hear. So what did we learn? Basically, whenever a sound is produced, it reaches your ears to the funnel part, then it goes through the canal inside and it reaches the eardrum. This eardrum starts vibrating. As it starts vibrating, it sends signals to the inner ear, and this inner ear further sends the signals to the brains, which helps us make out the kind of sound that we're hearing, right? So this is how our eardrum functions. Basically, we have now learned how our ears work and how we are able to understand sounds. What was the basic inference? It was that when a sound is produced, it reaches your ears, and through the funnel, through the canal, it goes up to the eardrum, which starts vibrating as soon as the sound touches the eardrum, right? This eardrum then sends signals to the inner ear, and then inner ear sends the signals to the brain. This is how we process the signals, and this is how we are able to hear and understand what the other person is saying or what kind of sound we are listening to. Yes? Now we have another topic in front of us, which is amplitude, time period and frequency of a vibration. Now students, had it been like there is only one kind of sound, we would not be able to make out the difference between different kinds of sounds, right? We have a different voice for different persons, we have different kind of sounds around us from a television, from a speaker, from a hospital, from our surroundings. Basically, there are innumerous kinds of sounds that we can differentiate. Now, how can we differentiate in these sounds? This is because these are the properties of sound as well. Each kind of sound that you hear has a different amplitude, time period, frequency and vibration, frequency of vibration, right? These are the three factors on which the kind of sound depends. We are able to differentiate different kinds of sounds because of the difference in their amplitude, time period and frequency. So let us see what are these parameters basically. The to and fro motion of an object is known as vibration. We have already learned that the to and fro, you can say that there is a pendulum, there is a to and fro motion of a pendulum, right? This pendulum, there is a pendulum, it moves in a to and fro motion, it shows oscillations, right? So this to and fro motion is known as vibration. This motion is also called oscillatory motion because these are oscillations. We have already learned that this is also called vibration or an oscillatory motion. Now the number of oscillations per second is called the frequency. Now students, we have learned that sound is produced due to vibration. Now when a body vibrates like this, there is a middle point. It goes from this middle point to this, then comes back to the middle point and then goes to this point, right? Let me write some points. This is the middle point. A body moves here and then here, right, in both the directions, and this one time going here and then one time going here, then coming back to the middle point. This one cycle is known as a vibration, right? Now the number of oscillations per second is called a frequency, right? For example, if a body is able to move, this is the middle point, and 1, 2, 3, 4, this is the body touched 2 times this point and 2 times this point. So what is the number of oscillations? The number of oscillations made are 2 because 1 and 1 counts for 1 oscillation, right? This body moved in this direction, then it moved in this direction, then it came back to the mean position, which is its center point. This is 1 oscillation. Now if this body travels 3 times in 1 second, then its frequency will be 3 hertz. We represent the frequency in hertz and its symbol is Hz basically, right? So now we have understood that the number of oscillations per second is known as the frequency of a sound, right students? A frequency of 1 hertz is 1 oscillation per second. A frequency of 1 hertz is basically, this is our body, right? This is our body, consider. Now it has moved from here, then come to mean position, then here and then to mean position, right? This is 1 oscillation. So if a body has 1 oscillation per second, then the frequency becomes 1 hertz. If it has 3 oscillations, 1, 2 and then 3. If there are 3 oscillations in 1 second, then the frequency becomes 3 hertz. And if there are 4 oscillations and so on, we write the frequency according to the number of oscillations, right? Now, amplitude and frequency are two important properties of any sound, right? We have learnt about frequency, what frequency is, right? We have to learn about amplitude now. Let us start. How are we going to learn the amplitude? Basically, what you do is you take a glass tumbler, you take a steel tumbler basically, and now you hit the steel tumbler with a spoon, right? You have a spoon and you have hit the glass tumbler with the spoon gently. In the first case, you hit the glass tumbler, the steel tumbler gently, right? This is, you can also take a glass tumbler because it also produces sound. So, when you hit the glass tumbler gently, there is a sound produced, right? Now, in the second case, you take the spoon again and you hit hardly. You hit the glass very hard, right? Now, the sound produced is very loud. It is very different from the sound produced in the first case when you hit the spoon gently, right? There are two kinds of sound produced. Now, the third case is you suspend a small thermocol ball. This is a small thermocol ball touching the rim of the tumbler. Now, you are touching the rim of the tumbler with the help of this thermocol ball, right? Vibrate the tumbler by striking it. Now, you again hit the spoon and you vibrate the glass, right? See how far the ball is displaced. As the glass starts vibrating, this ball moves far, right? This ball moves farther away. This ball is displaced. The displacement of the ball is a measure of the amplitude of the vibration of the tumbler, right? Now, the distance travelled by this ball, the displacement, is basically the amplitude of the vibration of this glass tumbler, right? Now, strike the tumbler gently and then a little harder. Now, you are striking it two ways, again using the same technique that we used here. Firstly, you hit the glass gently and then you hit the glass very hard. Now, compare the amplitudes of vibration. When the glass is hit gently, the thermocol ball will only move to point A, which is closer. The vibration will be very small, but this was case 1 when we hit gently. Now, when there is case 2, when you hit the glass very hard, the ball moves very far to point B, right? And it is where when we hit hard. So, what did we learn from this? This basically tells us that the amplitude depends upon the vibration of the sound, basically how strong the voice is, how much basically the loudness of our voice depends on the amplitude, right? You hit very hard, the sound is very loud and the amplitude is higher, amplitude is larger, right? So, what did we learn? In which case is the amplitude larger? The amplitude is larger in the case when we hit the glass very hard. Take care, you do not have to break the glass, you just have to produce two different sounds. One of them must be feeble and one of them must be very loud, right? So, what did we learn? We learned that amplitude is directly related to the loudness. Let us see. Loudness of sound is proportional to the square of amplitude. Basically, loudness is proportional to the square of amplitude. If amplitude is 2, right? Let us see, for example, if the amplitude becomes twice, for example, if the amplitude earlier was x, so the loudness is proportional to x square. But if the amplitude now is 2x, now the amplitude is 2x, the amplitude has doubled, then the loudness is directly proportional to 2x square, which is 4x square. Right. So, now we understand that the loudness is directly proportional to the square of amplitude. If you change the amplitude, the loudness will change with the factor of square of the amplitude, right. So, loudness is very, very much related to amplitude and it is much higher than amplitude as well. Now, if the amplitude becomes twice, the loudness increases by the factor 4. We saw earlier the amplitude was x, so the loudness was directly proportional to x square. But now we doubled the amplitude and now the loudness is directly proportional to 4x square. The factor is 4 now, directly, because we are dealing with a square factor relationship between loudness and amplitude. The loudness is expressed in the unit called decibel, which is represented as the we are indicating it as dB, small d and capital B. The following table gives us some idea of the loudness of some sounds coming from various sources. Let us see. Normal breathing produces a sound of 10 decibel, which is audible to us. We are easily able to hear it, and it is very soft as well. Now, soft whisper at 5 meter. If I am standing 5 meters away from you and I whisper softly, then the sound produced will be of 30 decibels. Then normal conversation is about 60 decibels. Then busy traffic is 70 decibels and average factory is 80 decibels, right? Above 80 decibel, the noise becomes physically painful. Above 80 decibels, it is not pleasant to hear that sound. It becomes noise for us, right? Let us see relationship between amplitude and loudness. Students, the loudness of sound depends on its amplitude, right? Also, students, after this we are going to discuss about the time period. Now, the loudness of sound depends on its amplitude. We already learnt. When the amplitude of vibration is large, the sound produced is loud. As I told you, loudness is directly proportional to the square of amplitude. So, obviously, if amplitude is increasing, the voice becomes louder, right? When the amplitude is small, the sound produced is feeble. So, when a child speaks, normally it means that the amplitude is very small and hence the child is not very loud. But if you listen to a man shouting, the amplitude is higher and hence the man sounds very loud. That is for the speakers as well, for the amplifiers that you have around you. Those amplifiers are basically used to amplify the amplitude only. They increase the amplitude and hence the voice is very, very loud. Right, students? This is the relationship between amplitude and loudness. Also, one thing that we left is the time period. Time period basically is the inverse of frequency. Time period is equal to inverse of frequency. What is frequency? Frequency, we learned, it is the number of oscillations in 1 second, right? So, what is the reverse of this frequency? It is basically that the time taken by one oscillation is known as time period. So, basically what is time period? Time period is, let us write it somewhere. Time period is the time taken by any object to complete one oscillation. Let me explain it to you. There is a body, this is the body, right? This is the body. Now, it vibrates from here to here. Now, the time taken by this body to reach point A, then reach point B, and then reach its middle point C again. The body is moving from C to A, then A to C, then C to B, and then again B to C. This is one oscillation. Right. So, the time taken by this body for one oscillation is known as the time period. Right. And frequency is just the opposite. Frequency is the number of oscillations done by a body in 1 second. Right. So, we have learnt what is time period, frequency and amplitude. Now, we are on to the next topic, which is pitch of the sound. Now, what is the pitch of the sound? The frequency determines the shrillness or the pitch of the sound. Now, students, we learned what is frequency. Frequency is the number of oscillations made in 1 second by a body, right, by a vibrating body. Now, higher is the vibrations, higher is the pitch. The vibration, if the vibration is very, very high, then the pitch is very high. For example, you can listen to any opera singer. The pitch is very, very high because its vibration, her vibrations are very, very fast. The oscillations are very, very high. The number of oscillations is very, very high. Frequency is very high and hence the pitch is very high. So, that kind of voice is very shrill. It sometimes also hurts our ears, right? It is very sharp voice. If the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch, right? If I shout in a very feminine voice, it will have a very high pitch and hence it will be very shrill, so it has very high frequency. Now the frequency, if the frequency of vibration is lower, we say that the sound has a lower pitch. You have two examples in front of you. In the picture 1, the boy is beating a drum, right? The drum noise is not very shrill, it is very not soft actually, it is a very normal voice, you can hear it clearly, and it is loud as well. So it has a higher pitch. You can listen, you can look at the frequency chart of this sound as well. The frequency is, the amplitude is much high, right? So we are able to clearly hear this voice and it has a higher pitch. Now there is a second example, the boy it has a whistle in his hands. Now he blows the whistle. Now what happens is, the whistle produces a sound with this frequency. Now what is the difference between the frequency of a drum and in the frequency of a whistle? You can see that the number of oscillations, if these are the number of oscillations made by a body in 1 second and these are the oscillations made by a body in 1 second, then what is the frequency? You can see, you have to count, this is one completed cycle. Let us see, from here to here is one cycle, right? So this body basically has completed 1, 2 and 3 oscillations in 1 second. So the frequency becomes 3 Hertz, right? In the case of whistle, what do you see? It basically is 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8 and then 9. Basically this body has 9 oscillations in 1 second. So the frequency becomes 9 Hertz. So you can see that the higher pitch is of whistle, the shrill voice is of the whistle, while the drum has no shrill voice. It has lower frequency, while the whistle has higher frequency. This is why the voice of the whistle has a very higher pitch, it is very shrill. So now we have understood the concept of pitch as well. We basically learned in this chapter, in this lecture about amplitude, frequency, time period, pitch of the sound, loudness, right? So we have now learned why there is a difference in the different kinds of sounds. It is because of the different properties of sounds, which are amplitude, frequency, time period, loudness and pitch of the sound. Loudness is basically directly proportional to the square of amplitude, right? Thank you for your attention, students.